Okay, unit 4. We're on unit 4. So rational polynomial functions, well, we just call them polynomial functions. I got to get a pen up here, I guess. So, whoops. Polynomial functions. Unit 5. Unit 4. Thank you again. Okay. Now, a lot of this is going to be review from grade 11. Like, we're going to see things in grade 11. We did reciprocal functions, but we also did that in the transformations unit. So reciprocal functions. What's an example there? Y equals 1 over x plus 3. Something like that. It is a polynomial function still, the way it is. Okay. Being that the one we can consider a polynomial, it's rational, it's a function, okay? But in grade 11, we learned it all that fancy with the vertical asymptotes, the horizontal asymptotes, the x-intercepts, the y-intercepts, and all that kind of stuff. Let's go through it again just for fun here. Let's change the color because we can. Vertical asymptotes, that comes from the bottom right. So what would be the equation of the vertical asymptote here? Oh, that sounds like a test question you just did, eh? -3. Okay. The horizontal asymptote, we went by rules. Now, yeah, this is going to be 0 because the up top, the degree up top is less than the degree in the bottom. Our x-intercept, or let's go with the y-intercept. That one's a little bit nicer to deal with. Our y-intercept, we plug 0 into x. What do we get? 1/3, Louisa says. So 1/3. And then our x-intercept, obviously, because there's no x in the numerator, there isn't one, right? So none. Okay, so again, this is all from grade 11. I guess we can put grade 11 and just put it there. So if we went and graphed this, and this is just an example, vertical asymptote at 1, 2, 3. -3. Horizontal asymptote coming across here at 0. And then we've got a y-intercept at 1/3, so about there. And we can see that our graph then is probably just going to follow up like so. And then we can do a table of values point, but we know already from transformations that it's going to go like this. Okay, so that's an example of how we dealt with some rational polynomial functions in grade 11. Just the beginning of what you already know how to do. Okay? Oh, I guess I can go back, eh? Sorry. Anna was still writing. Good? Okay. Let's kind of jump into it now. Let's talk here. Points of discontinuity. So points of discontinuity. We know vertical asymptotes, right? That's the one thing that we kind of seen before. And we get the vertical asymptotes from when the denominator equals what? What does the denominator have to equal to get a vertical asymptote? Two? 0. Yes, 0. When the denominator equals 0. Okay. I thought you said 2. Okay, so that's one example of a point of discontinuity. We've also got new ones that come in, and we call them holes. Yes, holes. We'll actually put holes in graphs. I talk about this a little bit with you in grade 11, but we don't actually go any further with it. Okay? And a hole comes when you've factored and canceled something. So a whole factor, okay? So holes come, let's put here, when factors cancel. Okay, something simple. So I've got a good example here Y equals x squared minus 9 over x minus 3. This is a good question to show the holes, not necessarily a vertical asymptote, because it's sort of like a vertical asymptote. It's an x squared. Yeah. Because if we were just in grade 11 right now, what would we say the vertical asymptote is? 3, right? But remember in grade 11 when we had learned how to simplify this stuff, we would say y equals factor and cancel, right? So up top we've got a difference of squares, so I'd have x minus 3, x plus 3 over x minus 3. Now it changes. So I like to think of a hole as where your graph gets confused with itself. It's not sure. Am I a vertical asymptote or am I not? Okay? Because right now, this x minus 3 in the bottom, here, it's not really a vertical asymptote because we cancel it with this guy and it's gone. But that factor of x equals 3 is a hole in your graph now. Because like I said, it wanted to be, but it also wanted to be an x-intercept, didn't it? Because this up top would have been an x-intercept, x equals 3. So when your graph's confused, well, I'm a hole. I'm just going to drop out of this altogether. Okay? So now when you would go and graph this, if I quickly throw a graph up just so you can see, we really have the equation y equals x plus 3 that we can graph. Well, have we ever seen y equals x plus 3 graphed before? In grade 9? mx plus b. So if I go and plot this, 1, 2, 3. So there's my y-intercept at 3. I'm going to go up 1 and over 1. So I've got a line something like this. Beautiful. But we have discovered, because we canceled that factor out, it creates a hole at x equals 3. So over here at x equals 3, up on my graph, there's actually a hole in your graph. It doesn't exist there anymore. So when you start going along your graph and stating the domain, for instance, on a straight line, what was our domain in grade 10, for instance? Always x element of the real numbers. Can I say that for this one? No. What's the domain on this one now? X can't equal 3, right? So your domain changes now for this whole function. So we can say the domain x cannot equal 3. There's your domain. Same with the range. If we had to go and find the range changes too, because obviously there's a hole somewhere when x equals 3. So if you went and threw x equals 3 in there, you know, in the original function, something happens. Okay? Any questions on holes? Because that's one of the new concepts. Yeah, we do. I touch on it in grade 11. Yeah, just a little bit. Hey? Yeah, that's a little different. Yeah, that's when we deal with radicals. Okay? Let's see. Let's do another example of this one. Change the page. Everybody had that? Sorry, I didn't ask, but let's go and do a full example now. I got f of x. Let's change it into some functional notation. Kind of talk the right language. Let's say for no, let's not. Let's not do that one. Let's change that up. Sorry. Oops. Let's go with x minus 2 over x squared minus 4. Show you a different one. Okay, this one won't work out to be linear, but it'll involve that stuff we did in grade 11. Okay, we'll do this one more example and then we'll pause it for a second. So, first things first, we got to factor and cancel. Factor and simplify everything. Okay? So f of x equals x minus 2, x minus 2, x plus 2, difference of squares again. It's nice, simple. Well, I see that I got factors that cancel, so right away I got to state all my points of discontinuity. So I've got a hole at x equals 2. And when I write this one step further, 1 over x plus 2, I also have a vertical asymptote at where? At negative 2. So now I've got 2 points of discontinuity on this graph. Everything else is pretty simple. Like you just said, we've got a reciprocal graph here again. So if we go like this one will maybe graph the grade 12 way, I'll call it. Okay, where we actually use the rules of a reciprocal graph. So 1, 2, 3. You have a question there, Abby? Okay. Okay. So I'm going to graph just the original function, the linear, just like last unit. Graphing reciprocal functions. So I've got a y-intercept at 2. I have the slope of 1, so up 1 over 1. And then x-intercept of negative 2. So there would be the original function, or the denominator function of that reciprocal function. Now, is that the graph at all? No, it has nothing to do with our graph, really. Like, it's kind of going to be gone eventually. So now I know that my vertical asymptote ends up being where the x-intercepts are, and we can see that anyways. We found that right off the hop. So I got a vertical asymptote going down through negative 2. I've got invariant points at what values? 1 and negative 1. So I've got an invariant point when y equals 1 and when y equals negative 1. Do I need any more than that? No, because I know I have a horizontal asymptote going across where? Yeah, the x-axis, because it's a reciprocal function. So I can keep graphing this now. So I know this graph goes up like that, and it's going to be going down through there, and here, and here. What do I have to make sure I put on that graph now, though? Yeah, the hole. So whether you just take your pencil and you circle it or whatever you want to do, we've got a hole at x equals 2. So I actually go to x equals 2. Now, the mistake a lot of people do is they go right on the x-axis and put the hole. You got to put it on your graph. So the hole is right there. I got to show that. And even if you write it like this, hole at x equals 2, whatever it is, so that they know that you've got your hole there. Yeah, well, no, in this case, you can do that. That's fine, Anna, but if you're stating it here, like we did, this is going to be fine. Yeah, totally. Yeah, you're showing it. I mean, if you want to erase that little blue in there or whatever, go ahead. Okay.